The ground beneath Florida is not solid. It never was. Right now, in neighborhoods where children ride bikes and retirees tend gardens and families sleep without a second thought, the earth underneath them is dissolving, not cracking, not shifting, dissolving, chemically, silently, and at a rate that geologists monitoring the state's subsurface infrastructure are describing in language they rarely use outside of scientific journals. The limestone platform that Florida sits on, the same ancient rock that has supported every road, every building, every city the state has ever built, is being eaten from beneath by water that has been doing this work for 10,000 years. And for most of that time, the process was gradual enough that the surface barely noticed. That is no longer the case. In the past 18 months, Florida has recorded more than 1,200 confirmed sinkhole events. The number is not a projection. It is not a worst-case model. It is a count. And the scientists watching the data say the count is accelerating. The last time anything like this was documented in the modern record, a single sinkhole opened in Seffner in 2013 and swallowed a man alive in his bedroom while his family slept 30 feet away. That event produced 3 days of national news coverage and then disappeared from the public conversation. What it did not produce was a reckoning with the system that created it, because the Seffner sinkhole was not an anomaly, it was a preview. The Floridan Aquifer System, one of the most productive freshwater aquifers in the world and the source of drinking water for more than 10 million Floridians, runs directly beneath a layer of limestone that is, in geological terms, already structurally compromised across hundreds of square miles. The question that hydrogeologists have been asking for a decade is not whether more sinkholes are coming. It is how many, how large, and how fast. The answers coming in now are larger and faster than any previous model predicted. Here's what makes Florida geologically unlike anywhere else in the continental United States. The entire state sits on a platform of carbonate rock, limestone, and dolomite that was formed at the bottom of a warm, shallow sea roughly 25 to 35 million years ago. When that sea retreated, it left behind a porous, layered rock structure riddled with natural cavities, tunnels, and voids that formed as ancient organic material decomposed. That rock platform is not hard and impermeable the way granite bedrock is. It is chemically reactive. When slightly acidic water, the kind that forms naturally when rainwater absorbs carbon dioxide from the atmosphere, percolates down through the soil and contacts limestone, it dissolves it. The scientific term for this process is karstification. Florida is one of the most extensively karstified landscapes on Earth. The entire northern and central part of the state is underlain by what geologists call karst terrain, a landscape defined by its own slow destruction from below. Dr. Clint Cromhout at the Florida Geological Survey has described the karst system beneath Florida as a landscape in continuous transition. The cavities that form in the limestone do not stay stable, they grow. The water that created them keeps moving through them, and as it moves, it carries dissolved limestone with it, enlarging the voids, thinning the rock ceiling above them, reducing the structural capacity of the layer that everything above it depends upon. For most of the past century, this process was offset by hydrostatic pressure, the pressure of groundwater inside the aquifer pushing upward against the underside of the limestone ceiling and effectively supporting it from below. The aquifer was full, the pressure was maintained, the surface held. That equilibrium is breaking down, and the reason it is breaking down is something that did not exist 10,000 years ago, did not exist 100 years ago, and in some cases did not exist 30 years ago. The reason is 21 million people, and what 21 million people do to the water table every single day. Florida's population has grown by more than 4 million people in the past 15 years alone. Every one of those people needs water. Every agricultural operation, every golf course, every car wash, every municipal swimming pool, every paper mill operating in the state needs water. The primary source of that water is the Floridan Aquifer. Withdrawal rates from the aquifer have increased dramatically with every decade of population growth, and the consequence of that withdrawal is not invisible. When water is extracted from a porous rock formation faster than it can be naturally replenished, the pressure inside that formation drops. The hydrostatic support that was holding the limestone ceiling in place from below weakens. Cavities that were stable under full pressure become unstable under reduced pressure. The ceiling thins, the void below it grows. And then, on a morning that looks exactly like every other morning, the remaining rock layer fails and the surface collapses into the space below it. The man in Seffner did not die because of one sinkhole in one neighborhood. He died because of a systemic failure that had been building for decades across a platform the size of a state. The 1,200 sinkhole events recorded in the past 18 months are not uniformly distributed across Florida. They cluster, and the clusters follow the aquifer withdrawal maps with a precision that researchers at the University of Florida's Water Institute describe as statistically inescapable. The heaviest sinkhole activity is concentrated in Hillsborough, Pasco, Hernando, Marion, and Alachua counties, precisely the counties where agricultural and municipal groundwater withdrawal is highest, precisely the counties where the limestone is thinnest and the karst cavities most developed. The clustering is not coincidence, it is causation, and the geographic spread of the clusters is expanding northward and southward from its historic center, following the expansion of water demand as the population disperses. On the morning of March 4th of last year, a sinkhole opened in a residential neighborhood in Land O'Lakes in Pasco County and reached 45 feet across and 30 feet deep before county engineers could establish a safety perimeter. 3 homes were condemned within 6 hours of the initial collapse. A fourth was evacuated when monitoring equipment detected subsurface vibration indicating a secondary collapse was forming beneath the adjacent lot. The family in that fourth home, a couple and their 2 children who had lived there for 11 years, left with what they could carry in 90 minutes. The house is still standing. The ground beneath it is not. Pasco County leads the state in documented sinkhole activity. Its aquifer withdrawal rates have increased 38% since 2010. The county's emergency management office has been quietly mapping subsurface void locations using ground-penetrating radar since 2021. The map they have built is not publicly available. When a local journalist requested it under Florida's public records law last spring, the request was denied on the grounds that releasing it could cause unnecessary public alarm. That phrase, unnecessary public alarm, is doing an enormous amount of work in the sentence that contains it. The limestone beneath Florida does not dissolve at a constant rate. It accelerates. The geochemistry of karstification creates a feedback loop that most people have never been asked to understand, but that has direct consequences for everyone living above it. When a cavity forms in limestone and acidic water begins moving through it, the walls of the cavity present a larger surface area for dissolution. More surface area means faster dissolution. Faster dissolution means a larger cavity. A larger cavity means even more surface area. The process is self-amplifying. A void that takes 1,000 years to reach 1 foot in diameter may reach 10 feet in diameter in the next 100 years and 50 feet in diameter in the decade after that. The acceleration is not linear, it is exponential. And the exponential phase is exactly where large sections of central and northern Florida's karst terrain currently sit, based on analysis of dissolution rate data compiled by the Florida Department of Environmental Protection over the past 25 years. The aquifer itself adds another dimension that the sinkhole count alone does not capture. The Floridan Aquifer is not a single underground lake. It is a layered system with distinct upper and lower zones separated by confining layers of less permeable rock. The upper Floridan Aquifer is where most groundwater extraction occurs. The lower Floridan Aquifer sits beneath it, under higher pressure. When withdrawal from the upper zone is heavy enough, the pressure differential between the 2 zones can drive water movement through natural or human-created conduits in the confining layer, dissolving that layer from both sides simultaneously. Hydrologists call this interaquifer leakage. It is the geological equivalent of removing the floor joists while still standing on the floor. There are currently 14 documented zones of interaquifer leakage in the state, concentrated in the same counties where sinkhole activity is highest. There are likely more zones that have not yet been identified because identifying them requires intrusive subsurface testing that is expensive, time-consuming, and politically uncomfortable for counties whose property values depend on the perception that the ground beneath them is stable. The economic consequences of what is happening beneath Florida are already measurable and almost impossible to overstate. The Florida Office of Insurance Regulation reported that sinkhole-related insurance claims in the state exceeded $2.1 billion in the most recent fiscal year with complete data. That figure does not include the claims that were denied, disputed, or settled below their actual cost. It does not include the property value losses in neighborhoods where sinkhole activity has been documented but not yet produced a catastrophic collapse. It does not include the municipal infrastructure losses, roads, water mains, stormwater systems, that Florida counties are absorbing without triggering formal insurance claims. And it does not include the coming wave of claims as the 1,200 most recently documented events produce their full legal and remediation costs through the system over the next 3 to 5 years. The insurance industry has been responding to this exposure not by improving coverage but by retreating from it. 11 major property insurers have reduced or eliminated sinkhole coverage in Florida since 2021. Homeowners in the highest risk counties who lose their existing policies are finding that replacement coverage, if available at all, comes with sinkhole exclusions that effectively transfer the full financial risk of a collapse event to the homeowner. The people most likely to experience a sinkhole are the people least likely to be financially protected when one occurs. Beneath the city of Ocala in Marion County, something was detected in late 2022 that triggered an emergency consultation between the Florida Geological Survey, the St. Johns River Water Management District, and the United States Geological Survey. Ground-penetrating radar surveys commissioned after a cluster of minor subsidence events, small depressions and cracks appearing in parking lots and residential streets, revealed a void system beneath the downtown area that extended approximately 200 meters in one direction and had ceiling thickness measurements in some locations of less than 4 meters. 4 meters of rock between the surface of a city and empty space below it. The shopping centers above it, the utility corridors, the water mains that supply 60,000 people. Marion County Emergency Management was briefed. Remediation options were assessed. The void is too large and too complex to fill using standard grout injection techniques. The current approach is monitoring, placing sensors that will detect changes in the void geometry and provide some warning before a catastrophic surface collapse occurs. The lead geologist on the project, when asked during an internal briefing what adequate warning time would look like in a worst-case scenario, gave an answer that was recorded in the meeting notes and has not been released. What has been released is the decision to continue monitoring. That decision was made in the fall of 2022. The sensors are still recording. The void is still there. The drinking water dimension of this crisis is the one that reaches beyond Florida's borders and into a calculation that affects the entire southeastern United States. The Floridan Aquifer underlies not just Florida, but parts of Georgia, South Carolina, and Alabama. It is one of the most productive freshwater aquifers in the world, capable of yielding millions of gallons per day from individual wells. It is also being drawn down in a way that has no clear endpoint. The Florida Water Management Districts, which govern groundwater withdrawal permits across the state, have been issuing minimum flow and level rules for portions of the aquifer since the 1990s. Those rules set thresholds below which withdrawal is supposed to be curtailed to protect the system. Multiple sections of the aquifer are currently in violation of their own minimum flow thresholds. The permitted withdrawals that are producing those violations are economically and politically difficult to curtail because they are held by agricultural operations, municipal water utilities, and industrial users whose activities depend on continued access. The water table is declining in areas where it was already dangerously low. The limestone ceiling above a declining water table loses its hydrostatic support faster than a ceiling above a full aquifer. The sequence from here is not complicated. Lisa Morales moved her family into a 4-bedroom house in Wesley Chapel in Pasco County in 2019. She researched schools, commute times, flood zones. She did not research sinkhole probability maps because she did not know they existed. When a depression appeared in her backyard in the winter of 2022, she called the county. The county sent an inspector. The inspector marked a 6-foot circle in orange spray paint around the depression and told her to keep her children away from it. 3 weeks later, the depression was 11 feet wide. 6 weeks after that, it was 22 feet wide and 8 feet deep. Her homeowner's insurance policy had a sinkhole coverage endorsement she had been paying for since 2019. The insurance company sent an engineer who classified the event as sinkhole activity, rather than catastrophic ground cover collapse. A distinction that under Florida, law triggered a repair obligation rather than a replacement obligation. The repair was a grout injection that cost the insurer $40,000. Did not address the void system identified 30 feet below the injection point, and was completed in a week. Lisa and her family moved out the following month. They are renting in a county that is not on the highest risk list. She still owns the house in Wesley Chapel. No buyer has made an offer. When can we go back? Her youngest son asked when they left. She told him she did not know. She was not lying. The state of Florida has known about the karstification acceleration problem since at least 2010. When a legislative task force produced a report recommending mandatory sinkhole risk disclosure for property transactions, a statewide subsurface monitoring network, and a review of aquifer withdrawal permits in the highest risk counties. The disclosure requirement passed in weakened form and was further amended in 2011 to reduce the burden on sellers. The PISA-wide statewide monitoring network was not funded. The withdrawal permit review produced no changes to existing permits. The 1,200 sinkholes recorded in the past 18 months are, in part, the consequence of decisions made in the years that followed that report, not decisions to do the wrong thing. decisions to do nothing. In geologic systems under exponential stress, doing nothing is not a neutral choice. It is a choice to inherit a larger version of the problem later. Florida is now later. 21 million people live on a limestone platform that is dissolving beneath them at a rate driven by their own water consumption, accelerated by exponential dissolution chemistry, inadequately monitored by underfunded agencies, and insufficiently disclosed to the homeowners, renters, and municipal governments who bear the full consequence when the surface finally gives way. The scientists watching the subsurface data are not issuing emergency declarations. Geologists do not issue emergency declarations. What they do is publish papers, attend conferences, send reports to water management districts, and watch the numbers climb. The numbers are climbing. The 1,200 sinkhole events of the past 18 months will be a baseline that future researchers look back at as the moment when the acceleration became undeniable. What comes after a baseline is not a plateau. It is a steeper slope. The aquifer is still draining. The limestone is still dissolving. The voids are still growing in the dark beneath cities and neighborhoods and schools and hospitals that were built on the assumption that the ground they were built on would hold. That assumption was always provisional. The geology of Florida made it provisional the day the first human being drilled the first well and pulled the first gallon of water out of the rock. The Earth does not negotiate timelines. It does not wait for funding cycles or legislative sessions or insurance industry actuarial tables to catch up with what is already happening beneath the surface. It simply continues the process. It began 10,000 years ago. The slow, patient work of reclaiming what was always, in geological terms, a temporary arrangement. The only question left, the one that the sensors in Marion County are recording right now, the one that the GPS deformation data is tracking across the entire karst platform, the one that 21 million people living above it have not yet been clearly asked, is whether the surface will hold long enough for the decisions that were not made a decade ago to finally be made now, or whether the ground will answer that question first.